Current electricity numerical, July 2014. A network of resistors is connected to a 12-volt battery as shown in figure. Here this is your simple network of resistors that is connected to a 12-volt battery. A. Calculate the equivalent resistance of the network. B. Obtain current in 12 ohm and 6 ohm resistors. Okay, you need to find the current through this 12 ohm resistor and a 6 ohm resistor. Here what we are given? We are given that the EMF or potential difference of a cell or a battery is given, that is 12 volt. We are assuming that R, internal resistance of the cell, is 0 because we are not given small r internal resistance. Therefore we are taking E or V is equals to 12 volt. R1, that is 12 ohm. R2, 6 ohm. You need to find the effective resistance of this combination. Here two resistors are connected in parallel, and also we need to find the current through 12 ohm and current through the 6 ohm resistor. Okay, let's find the effective resistance of the combination. That 1 by Rp is equal to 1 by R1 plus 1 by R2. Here we have only two resistors connected in parallel. 1 by Rp is equal to cross multiply R2 plus R1 divided by R1 into R2, or that Rp is equals to, we can write R1 into R2 divided by R1 plus R2. Now what is R1 here? R1 is, that is 12 ohm and R2 is 6 ohm. Therefore that is 12 into 6 divided by 12 plus 6. 12 into 6, that is 72. 12 plus 6, 18. 72 by 18, here that is 4. Now the effective resistance of this network or a combination is 4 ohm. We know that when two resistors are in parallel, the potential difference across each resistor is same. When you connect resistors are in parallel, the potential difference across each one is same. Now it is applied potential is 12 volt, and therefore here the current across the 12 ohm resistor, that R1 is I1 is equal to V by R1. What is V? V is potential difference across the R1, and here R1 is resistance of the resistor, that is 12 ohm. 12 volt by 12 ohm. Here I is equals to 1 ampere. Now current across the 6 ohm resistor, that is current through our second resistor. We know that what the potential difference across this second resistor is also 12 volt, and here resistance is R2 is equal to 6, and we know that I2 is equals to, we can write V divided by R2. That's what here we have. What is that? I2 is equals to V divided by R2. V is 12 volt and R2 is 6 ohm. Therefore I2, current through the 6 ohm resistor, is 2 ampere. The current through the first resistor, that is 1 ampere, second resistor is 2 ampere, and effective resistance of the combination is 4 ohm. Here what is that? We need to calculate the equivalent resistance. Equivalent resistance is 4 ohm, and obtain current in 12 ohm. Current in 12 ohm is, that is 1 ampere, and current in 6 ohm resistor is, that is 2 ampere.